Hello class, so today we want to look at introduction to atomic physics. Introduction to atomic physics. Now, atom. We know what we call matter, and it is understood. If you understood that when you divide matter, you get to a point where you get a structure, and that structure is referred to as an atom. But to get this studies well, there are many scientists that has come into play to discover what this particular atom is. And the physics behind this particular atom brings about the subject matter atomic physics. Now to start with it, around 460 BC, there was a scientist, a man by name Democritus. He's sometimes seen as the father of atomics or atomicism because he's the one that started the whole theory about atoms or the whole concept about atoms. That is over, he existed 460 years before Christ came into being. And that is over 2,000 years ago. Now what happens is that there was a teacher known as Leucippus or Leucippus. This man was the teacher of Democritus. He was the teacher of Democritus, and sometimes he's seen as the one that gave the brain behind atom. But Democritus' studies was not based on any scientific experiments. Democritus' studies about atoms was not based on any scientific experiment. That is to say, it was not based on any tested facts. He only sat and by his deep thought, he could bring about atoms. And this is why he said one. After the deep thought of Democritus, he said one, matter cannot be destroyed. So this is the first thing Democritus said. He said one, matter cannot be destroyed. He said two, matter can be subdivided. Matter can be subdivided. Can be subdivided. So this the first thing Democritus said is that matter cannot be destroyed, and again he said matter can be subdivided. But matter can be subdivided, that is to say it keeps dividing until it gets to its limit. So matter can be divided, or it keeps divided until it gets to its limit. Now, the limit to which matter cannot be divided again, or beyond this limit, there is what we call indivisible particles. Beyond this limit, there is what we call indivisible particles, and he said these indivisible particles are known as what? Atoms. These indivisible particles are known as atoms. Okay. So now this is what he said. Matter cannot be destroyed. Matter can be subdivided. But as matter keeps dividing itself, it will get to a point where it cannot be divided again. And the point it cannot be divided again, that point, the structure we get at that point is what we call atom. So simple, you can put this that matter is made up of tiny particles. So tiny indivisible particles. Matter is made up of tiny indivisible particles called atoms. Which can neither be created. Nor destroyed. Which can neither be created nor destroyed. And this was the deep thought, or this was the fact Democritus brought up after his deep thought. But this was not considered years past. And as time went on, it was not considered because there was no scientific explanation towards that, because he didn't perform any scientific experiment. Now, since that was not done, you all came into the studies where other scientists came into being. to bring about the atomic structure model. To bring about the atomic structure model. So now, if you want to look at the models of the atomic structure, a lot of scientists have done their work. You want to look at the models of the atomic structure, a lot of scientists have done their work. And after Democritus, we come to a scientist known as John Dalton. He also brought his models on atomic structure, known as what? The Daltons atomic theory. He did well by bringing it known as the Daltons atomic theory. Daltons atomic theory. Now, after Dalton, he had a lot of limitations. He couldn't explain a lot of principles. So it was modified by a man known as what? J.J. Thomson. A man known as what? J.J. Thomson. He also brought his studies on atomic structure, and it was later on modified around the 20th century by a man known as Rutherford. That is Ernest Rutherford. After Ernest Rutherford, another scientist came known as Niels Bohr. Niels Bohr, who also came to do a marvelous work on atomic structure. And after Niels Bohr, you have the last scientist, that's Erwin Schrödinger. Erwin Schrödinger. Erwin Schrödinger. But all these scientists, from J.J. Thomson to Erwin Schrödinger, they all gave two basic facts about atom. From J.J. Thomson to Erwin Schrödinger, they all gave two basic facts about atom. And one, they said atoms have basic particles. Atoms have basic particles. Atoms have basic particles. And two, they said atoms carry no charge. Two, they said atoms carry no charge. Atoms carry no charge. So out of all the facts, the build-up, the modifications they brought into the models of atomic structure, these are the two basic facts J.J. Thomson and the Rutherford and Wassce they never touched, because it was true for all cases. Atoms have basic particles. Atoms carry no charge. For Democritus, he said atoms cannot be divided, but studies showed us that atoms can be divided into some atomic particles: the protons, the neutrons, and the electrons. But for the sake of this video, we want to look at Dalton's atomic theory. Dalton's atomic theory. Alright, so this is Dalton's atomic theory, and these are 6 postulates you can get from Dalton's atomic theory. So now, but before we start with it, we are going to use element A plus element B. That will give you compound C. I'm going to use this analogy to explain the Dalton's atomic theory. Now, the first postulate says that all matter is made up of very tiny particles. That was the first thing Dalton said. All matter is made up of very tiny particles, and atoms are indivisible particles. The atoms are what? Indivisible particles. That means that if you get an atom, what he said was that if you have an atom, that is, if you have an element is a matter, so if you divide the element, you realize that the smallest structure of the element that you will get. So this is the element A, this is the element B, the smallest structure of the element that you get. Can be subdivided again. And when you add it, you get what? Your compound C. So you get your A's, your atom A's, and what? Some of your B's around it. Are you getting it? So your atom of the A's and the B's coming together to form the compound C. So the atoms are what? Indivisible particles. That was the second thing he said. So anytime you divide matter into that tiny particles called atoms, you can't divide those atoms again. You can't divide those atoms again, because if you even react A and B, you still find what? AB in your compound C. That means there's no way you can divide the atoms again. Now the third point is that atoms of a given element are identical in mass and chemical properties. So what this simply means is that if this element A, so let's element maybe sodium element, the atom in sodium element is what? The sodium atom. So this atom, this atom, this atom, they have the same mass and they have the same chemical properties. So they have the same mass and the same chemical properties. The same way, the atom here in element B, all the atoms will have the same mass and they will have the same chemical properties. For atoms of different elements have different masses and different chemical properties. That is to say, if I take an atom from A, so this is an atom from A, and if I take an atom from B, you realize that the masses of these two atoms differ, and their what? Their chemical properties will differ. That is to say, the chemical property of sodium atom will be different from the chemical property of what? A hydrogen what? A hydrogen atom. And the weight of a sodium atom is different from what? The weight of what? A hydrogen atom. And that was also true. Atoms combine in a ratio of small whole numbers to form compounds. So what this means is that, so let's assume for instance, in the compound C here, you have maybe the B, and you have atom, put this inside. So the compound C here can have this. Okay, so after element A and element B are formed a compound. So the one needed is what? The atom. So you can have in the compounds, you can have 2 atoms of what? Of the element A and 1 atom of what? The element what? Element B. So now what happens is that always atoms, they combine in a ratio of what? Small whole numbers. That is, in other words, they are empirical formulas. Are you getting it? So now I can say that you have what? If 2 atoms of A, 2 atoms of A, and 1 atom of B, then you can have a compound as what? A2B. Do you get it? You can have a compound as what? A2B. So this instance, if you have water, what happens is that you have 2 atoms of water, of the hydrogen, and 1 atom of what? The oxygen, that is forming the compound what? H2O. So they always form a simple ratio. A simple ratio of small numbers to form the compound. You have 2 H to what? 1 ratio. And that is also true. Now when it comes to The last one says the relative number and kinds of atoms are constant in a given compound. The relative number and kinds of atoms are constant in a given compound. So what happens is that the atom here, the kind of the atom here will be the same as the kind of the atom A here. The kind of the atom B will be the same as the kind of the atom B here. And they are constant in what? In this given compound. Thank you very much for joining this video. Let's move on to D.D. Thomson's atomic theory.